Okay guys, welcome to the tutorial number 4. We've covered quite a bit of ground by now, and I wanted to get into one of the aspects that has to be included into your design, the detail aspect of your design, and it's related to the sun study that you have to consider. Now, the one aspect that I mentioned in the brief is that you have to look at the north view specifically, and that has to be allow you to have quite a nice uninterrupted view while you're working at a desk, working with pots, plants, samples, microscopes, whatever the case may be. And you've got this beautiful view to look at. The problem with this situation is that you're going to get a lot of sun coming in onto your desk, especially if you're working on a computer, on white paper, and it will damage the samples. So you immediately have to, there's a contradiction in the design that you have to you have to look out at the view uninterrupted. I didn't say how long that view needs to be, so it's up to you, but also you have to consider the amount of light that comes in, which is very uncomfortable. Now that light deals with two aspects. Of course, that source is from the sun, and as the sun comes in through that glass, not only is it creating heat, now that heat might be welcomed in winter, but you don't want it in summer. The second, that's the first thing, which is the heat or the temperature. The second thing you have to consider is the glare. Glare is another aspect of human comfort, and that deals with the kind of brightness of the sun coming in and then entering your eye, especially on white paper, and makes it hard to see on glass. So for that, you have to start looking at the sort of sun path study, and you've guys done sustainable design in first year, so without having to go into too much detail, you need to know the basic principles of what the sun study, the impact of the sun study on a typical condition like this. So what that means is that we'll look at it first over here. Well, let's look at we know that this line refers to summer in its most extreme case on the 22nd of December, and we know that that line relates to winter in the most extreme case in, I think it's the 22nd of June. So anything in between that, you're going to get, at some point, you're going to need to deal with the amount of harshness that relates to the summer sun. But in the winter sun, there could be a relative amount of comfort that you can achieve by allowing that kind of sun into your space. What this means is automatically I would start looking at this in section. But before I go there, I want you to look at the indication, the numeric indications. And this is fairly simple. So I want you to look at the degrees at which, for example, 12 o'clock being north. Let's look at it over here. In the winter sun, your sun is going to hit 12 o'clock north at which degree? If that's 10, 20, 30, 40. At about 40 degrees from the base, you're going to hit winter sun. But look at what happens in summer. 50, 60, 70, 80 degrees. That central point is 90 degrees. That number here that I'm circling represents, it's around 88, 87, 89 degrees. What this means, if you had to cut a section through this, what that effectively means is that your sun coming through, if that was full glazing, let me redo that diagram, need more space. What this means is, very simply drawn, that if this is 0 degrees, and that's 90 degrees, we mentioned that at around 40 degrees, if we had to do 45, x is equal to x, let's not get into maths, that's scary, that if that's 45, that 5 degrees short of this line will be the 40 degree line, and 2 or 3 degrees off from there would be your 88 or 89 degree line. What this means is that at the height of winter, your sun will hit that mark over there, but it will also throw your sun a lot deeper into that space. Of course, the sun's much further away. And let's draw this in purple. Your sun source will end up doing something like that and something like that. This would be the range that just diagrammatically, winter sun, summer sun. But that's not your problem only. Your problem is when the sun hits, if this is December 22 and this is June 22, what happens in November, what happens in September or October, August, so August is there, July, at about this point is where the heat starts generating. This is still winter time, but it's the degree to which it starts getting hot. So it's not only over there, it hits. If you have to be really true to this, you have to start looking at a range of times like that, and that is the problem. So I threw a curveball at you in the sense that the problem that you have to solve is that you have to limit, let's draw this, you have to limit the amount of sun while entertaining the view outside, and that's a problem that you'll have to solve. Now, there are a number of ways you could do this. So the one is, and I know you can do this in SketchUp and ArchiCAD, you can be 100% accurate, but for the sake of this, you can kind of, if you don't have access to it, you can do a thumb suck. So there's what they call, if I had to talk about a degree, let's make this thinner. If your view, if this is a person standing there and you want to get full access to the view, there's a number of things you can do. You obviously, the first thing to do is limit the glass. Now that's fine.
because it will not get into there. That's fine, because what will happen, the sun will only get into that portion, because you still get the view. I didn't say how much view you need, just a little, whether you're sitting inside, whether you get this amount of view, this amount of view, let's do it in a different color, this amount of view, or this amount of view, doesn't really matter. But you have to consider the climatic requirements here. Of course, expensive glass makes it look a lot better, but you have to rethink the practicality around that. Perhaps a meeting space is okay for a full expanse of glass, because you're talking in that space and you're not doing very expensive processes that can be damaged. So you really have to think about, where do you use expansive glass or not. So this is the one option. Option A, you limit the amount of exposure. B, you start looking at some kind of way of reflecting that sun. Horizontal louvers is a way of doing it. What that does is, when you're inside, you still get the view. It is obviously broken by the fins, but you still get that view. Option C, let's move this. Drawing out of the way. Go back there. I'm working backwards. Option C is if you do what they call a light shelf. So if you're in the space and you provide some kind of shelf that when the sun's path hits that glass, the shelf is in direct contrast or contradiction to where that sun would hit. What that allows you to do is to give you that view across, and what it does, it bounces the light from the sun into the space indirectly, so you won't get the discomfort of the glare. Essentially what we're doing is version B and version A are cousins of each other. It's just that this is a bigger version and a singular version of multiple of these. And then there are other iterations of which you can play with. You can have louvers that pivot in section. So you could have a doubled system where there can be glass. That's a person standing there. And you could go out and access these and maneuver and change these. That is option D. And then option E would be to create a deeper space so that your sun does not get to the glass. You can have a combination now. You can combine and make that solid, so that the sun, by the time it hits there, it's now not giving off so much heat and won't hit that glass. In these scenarios, what you'll have to do is you cannot put a desk up against a situation like that, because you're going to end up having, in the winter sun, lots of uncomfortable light coming through. So think about having your desks further away. Where I would put a desk close by is if you have a situation where the light shaft is of such a nature that it covers the worst scenario of the 40-degree sun, and your client is sitting here and the winter sun still doesn't get to you. Okay, I think that's enough for this little tutorial. Thank you.